4 functions. One of those requires the product rule to be able to differentiate it. One of those has got 2 separate functions multiplied together. So the first thing to do is to recognize when you need to use the product rule. Let's have a look at them. First of all, look at this. This is telling me what the variable is. That's the variable in this function. The f function here has an independent variable x. So if I were to sketch it on a graph, I'd be plotting the function up here and x along here. This function, t, is the independent variable, as we mentioned at the beginning of this course. So I'd be plotting a graph of a function, the function against time along the x-axis. This g function has x as the independent variable, and so does this function. So does this first one involve 2 separate functions involving x multiplied together? No, I can see you shaking your head. X only appears once. There is another variable t, but that's taken to be constant. This is telling me that this is the thing that's changing x. Any other letters in there that I don't know, any other variables, are constant. In any experiment, we only ever vary one thing at a time and see how that affects what we're interested in. We don't change lots of things at the same time. So in this situation, x is the thing that's changing, so t is a constant. I don't know what t is. I could, later on I might need to know it. I'm going to say, well, what about if t equals 2 or t equals 3? But it's not a variable, it's a constant. So this is not a function involving x twice. It's easy to differentiate. If I want to differentiate this function, the differential of the function with respect to x, remember that notation, we're using this notation this time, will be, just ignore the t. Bring the 4 down, looking at the exponential functions on your differential chart, it says bring the 4 down out of the exponential function, multiply it by what's in front, 4 5s are 20, 20t, can't ignore the t, but just leave it there. I mean, it's a number, I just don't know what it is. E to the 4x, that's the differential. So I don't need to use the product rule for that. What about the second one? Do I need the product rule for this? Have I got 2 separate functions involving t multiplied together? No. What's the differential of that function, David? No, not the same as the one above. This time t is a variable, so I'm differentiating with respect to t. So that means that all of this is a constant. The 5 and the e to the 4x is just a number. So it's like a number multiplied by t. So if I differentiate that, what happens? It's like I differentiated 4x, or 4t rather, sorry, 4t. What happens? The t disappears, doesn't it? And I'm left with just a number in front. So what's the differential of that with respect to t? 5 e to the 4x. The t just disappears. I'm differentiating with respect to t. What about this one? Have I got 2 functions involving x multiplied together? Yes. But do I need to use the product rule? Can I use algebra to help here? What's 3x times 5x squared? (15x cubed). So although I've got x appearing twice, I can actually combine them together to get 15x cubed. I can simplify it, in other words. So if x appears more than once, try and simplify. And so now the differential of that, g prime x, just equals, well, 15 times 3 is 45, x squared, take 1 off the power. So that's easy enough to do. What about the last one? Must be the last one, mustn't it? This one does require the product rule. How do I know? Because the independent variable, and that's signified by this, appears twice, two separate functions that I cannot combine together and simplify. So I would need to use the product rule to differentiate that function. And to do it, I'd identify the two separate functions and call one u and one v, and then apply this thing called the product rule. So let's have a look at that rule now together.